So let's begin. So hello everyone. My name is Mikołaj Koziarkiewicz. I'm actually currently more a machine learning engineer working at Software Mill. However, I've been working as a Scala developer for many years, and I'm also pretty excited for Scala 3. Right. So the topic of this presentation is implicit in Scala. What's going on with them, and in Scala 3 especially. So what's going on with them, and will there be finally an improvement? So just 2 words about Scala 3 and Dottie, because that may cause some confusion. So Dottie is originally the name of the compiler that was the candidate for Scala 3. It was based on a new type system, a formal type system, typed calculus actually. And it was being developed through several years. Eventually, the idea of Scala 3 has condensed into just being Dottie. So relatively recently, it was actually announced that Dottie is now Scala 3. I'm mentioning this because you can hear various names, and also like the primary documentation for Scala 3 is on the Dottie PFL site. So just so you know, this is basically the same thing. Right, but onto the topic. So let's imagine that you're approached by your colleague who is not a Scala developer. They just saw some Scala codes, maybe in work, maybe they're trying to learn, and they ask you this question. So I just saw this line of code with implicit with this keyword, right? So can you tell me what this means? And you then go, so it can mean extension methods, it can mean some scope dependency, it can mean a conversion to some other type, it can mean something called a type class, right? And so on and so on. And by the time you're done mentioning all the various meanings, your colleague is like, yeah, maybe let's not talk about Scala anymore. So this is, of course, a problem that is very well known in the Scala world. And of course, the creators of the language, including Professor Dottie, is also cognizant of this fact. So one of the things that received a very serious overhaul syntax-wise and also semantic-wise is the concept of implicits. So, as I've said, the problem is recognized, and what they tried is to unload the semantics of implicit. Essentially, they are splitting up each meaning to a separate keyword or a set of keywords. And you can still use implicit in Scala 3.0, but it will be deprecated over time in the subsequent versions, and it will then disappear finally. Okay, so as I mentioned, there are several meanings for this, and the first one is extension methods, which is a pretty popular thing. So an example of this is right here. As you can see, we just have an object that includes this extension block. The extension block has the keyword extension. It has the type that is being extended. In our case, that's an int, and the methods that we are extending it with. So here we have just x to the power of something for exponent and the square root, right? You can use this external keyword with the type on just one line if you only have one method that you want to introduce as an extension method. But here we just have a block because we have to, just for completeness sake. Right. So we know how to define it. How do we use it? Well, it's very simple. We just import it. Just use import implicit extensions underscore. And as you can see, we have here the usage it just works. It will just print out those figures as here, which are of course the correct ones. And you don't have to add implicit class or companion object, etc., etc. Just this extension keyword for adding the extension methods. And this, of course, works as well for operators. So here we defined an alias for the power. The alias has the similar syntax like in Python, so the double multiplication sign, so to speak. And it's called in the infix way. And as you can see, there's actually an infix keyword here for this. Strictly speaking, for symbolic names like well, non-alphabetic names like here, we don't need this infix operator. And at least on some versions of Dottie and Scala 3, you don't actually need this at all. You can just invoke it like this. But it's good to know about this infix keyword just in case we get a syntax change later on. Okay, so this is pretty much how extension methods work. That's all you need to know. The second problem is implicit scopes. So like you have an execution context on an actor system or stuff like that, right? And here we have a split. For declaration, we use given, and for parameters, we use using. How it works in detail, we'll see now. So this is a very naive method that very unsafely gets out an actor. And as you can see here, it has an analog to the implicit parameter declaration in Scala 2. It starts with a using keyword. All right, and this is basically a similar thing, right? Like with implicit. If you know arcane, you actually know one more thing, is that this resolve one method requires also a timeout. And this is also in Scala 2.x is an implicit, so the equivalent of a given right now, right? So what you would do here in Scala 2 is just write comma time TO or something timeout, right? But what you can do in Scala 3 is to actually have a separate additional parameter list for using. And for if you have just a parameter list with a singular member, you can safely omit the name of the alias of the given, right? You just don't have to mention it if you don't if you don't use it in your code. You just have to summon. You can just summon it by type, and this compiles even if you're using Akka compiled for Scala 2 point something. Right. So we now have the dependency declaration. What about the dependency definition? So for this use case, we use something called an alias givens. As you can see, we have an object, and we use this given keyword with the name and the type. We don't have the val keyword here anywhere because it pretty much has to be a val anyway, right? In this case. And we just define this given, which we can use later on. And the entire trick is now adding it to the usage of our method here for an import. And this is where there's a small change. So first of all, you can import this parameter here, this path here, just like in Scala 2 explicitly. So like here with an identifier. One thing that is new is that you can now say, I don't care about the name for this given, but I care about the type. So give me a given within type of actor system, right? This is very convenient because you don't need to look at the code for a library. Just say, I want this type. The other thing that's quite big for a change is that if you do it like this on the third example with wildcard, you will get an error. You will say you'll find out that this given is not being found for this type. That's because wildcards like this one, are no longer for the given or implicit scope. They are for the normal scope. If you want to import givens as a wildcard, you write it like this. So given without a qualifier, right? And you can, of course, also import everything, just like in Scala 2, with the wildcard for the normal types and the given for the unqualified given for the given scope. Yeah, and I personally think this is arguably better because it doesn't confuse as much. At least it doesn't confuse newcomers as much, since right now they are being told that there's very two distinct dissimilar scopes, and you need to take care to import from the right one. So you won't have like Java developers accidentally importing and everything for the given scope. They will have to know that this works. And as a bonus, there's one great thing in Scala 3. Better errors. So what happens now is that the compiler now tries to find the given instance that fits for the place that where it cannot find it. Of course, it cannot fix it automatically because there can be many different instances that fit for this particular type, right? And it will list all the ones that are possible. Here we just have this default, and it just says that it cannot find an actor system for the given, but you can probably import it like this and it will work. So I find that this will be very useful for libraries like like cats, for example, where the import hierarchy is not that transparent. And of course, for those libraries, you also can have custom error messages like you have in Scala 2. I think it's from 2.12 something, right? Yeah, but anyway, even if you don't have this custom message, if you're building a library, you get this out of the box, just like that. Okay, let's just cover the next thing, i.e. implicit conversions, which are, of course, normally a code smell. You don't want to use them too often, and you don't want to use them like this in particular. But it's just a convenient example. So let's look at this. So let's say you want to have a number that has delimiters for every 10 to the power of 3, right? Like this. And you just want to have this conversion just by forcing different type, well, a type of string, right? Because it's a string representation. So you write the conversion method here, like the apply, right? And you group it by 3, like to do the double reverse, so that it's actually the delimiters are actually in the right places. And now that you have that, you just create a specific type of given. The with here, by the way, is just like a block declaration, right? So it's just said that this is where the given starts, the body of the given starts. So we have a given with an optional name. And for implicit conversions, what is important is that you extend this type called conversion. And it's pretty straightforward. So as you can see, the in type is here, the out type is here, and that's pretty much it. And of course, like in Scala 2, you also have to have the right feature import, otherwise we'll get a warning. So again, implicit conversions are still not recommended for widespread usage, but if you have a need for those, this is how you can do it in Scala 3. And as you can see, it's also much more intuitive than it was in Scala 2. Finally, as far as drilling down goes, we can talk a bit about type classes. So for our very popular example of encoding JSON and parsing JSON, which we as Scala developers all know and love, and absolutely have no problems doing it in every project. Let's say we have this toy toy type of JSON, and we have this encoder type, like we could have in CRC or in a library. So as you can see, we again have an extension method. This extension method is a bit different because it is already parameterized. And how this works is that it automatically replaces the need for a separate syntax class. So once again, you have this code for this trait, and as you can see, we have just this toy method that requires an instance of encoder T for the type T, and as you can see here, we directly invoke the extension method on the type T. So if you have an encoder for type int and pass an int here, we just call the encode on this type. So much more convenient than in Scala 2, when you had to have a separate typecast trait and a separate syntax trait and instances for those, etc., etc. Right? And of course, if you've been writing stuff like that, you also know about context bounds. And this is pretty much the one thing that hasn't changed in Scala 3. It looks exactly the same, right? So you add a qualifier here, right, in the type parameter declaration, and those two things, using declaration and this context bound, are completely equivalent. One remark is that if you would have some other using parameter list here, this will be converted to the end. This will be pretty much a separate list in the end, which is also much clearer than in Scala 2, because in Scala 2, you essentially inject new names to the existing implicit list. So also quite nice. But the important thing is that you don't have to have a separate syntax class for typeclasses. One thing that's also important for typeclasses is, of course, derivation. Now, we won't cover it here because this would require a separate presentation in itself. But there is a new keyword that is called derives, and it's actually for automatically deriving typecast instances based on your data structures. So essentially, it partially replaces shapeless in Scala 3. It just baked into the language, which is very nice, because no more you don't have to understand a library that just works on implicits and has this special semantics and special calculus in implicit that you have to understand and keep in your head. You just have to understand how the derivation works in the language itself, and it's quite well described. This is the link for the explanation of that. So, starting our summary, in Scala 3, the keyword doesn't really exist. There's no use case where the implicit keyword remains. And if you think about it, it's a very good idea, because new developers will not encounter this at all and will be confused by the old results, search results, I mean. And all developers won't have this cognitive dissonance when they would encounter an implicit keyword somewhere in Scala 3. And they would also have this entire meaning of implicit left over from the previous version. So there is pretty much no implicit keyword. It is allowed still in Scala 3.0, but it is being slowly phased out. So it will become, some cases will become deprecated in Scala 3.1, and they will will they become completely invalid syntax, and so on and so forth. And to finalize our summary here, so this is a small dictionary for Scala 3. So for implicit scope, you have the given instances and the using parameters, plus the import changes that I've covered, right, with the two separate scopes. For extension methods, you have extension. For implicit conversions, you have given and using the conversion, right? One example that I haven't provided is that implicitly is also being replaced with the method summon. So again, everything that's called implicit is being eliminated in Scala free. And the typecasts are, sorry, my headphones got muted. And for typecasts, you actually have the combination of given using, right, for the instances, extension for syntax, and the derives for auto derivation. One important thing is try to first of all look into the current Scala-free documentation, because blogs that have been written even recently can have old syntax versions, because the syntax has evolved a lot over the last 2 years. So much actually that JetBrains went on a strike for a moment and said that they will not be producing Dottie support until the syntax gets stabilized, which it had. So now you can use it in the EAP versions of JetBrains, at least of JetBrains IDEs. But anyway, so first of all, look into this documentation first, and this is called the contextual abstractions as a section, and this specific link actually describes the motivation for using for the changes, and it also has some interesting information such as how many languages actually have an analog for implicits, which is more than you think. And it also covers stuff that I haven't covered in this presentation, like, for example, context functions, which will actually be presented by Adam. Yeah, and pretty much this is it. I hope you have gained some faith into some additional faith in the language after this presentation, and thank you for your attention, especially since this presentation was very much condensed. And of course, now I have to ask if there are any questions.